this Easy Ed video lecture, we will learn about mobile communications. We will study about cellular concept, mobile phone system, features of cellular concept such as frequency reuse and cell splitting, handoff procedure, and global system for mobile or GSM. When we have to call someone, we just take out our mobile phone and dial the required number. But has anyone ever wondered how these mobile phones work? What exactly happens when we make a call from our mobiles? Let's start with the cellular concept. We can make a call from one part of the country to another part of the country. Practically, every city is divided into small areas. Each area is called as a cell. Thus, a cell is defined as a basic geographical unit of a cellular communication system. Seriously, pay attention. This is important. As the city is geographically divided into small cells, it is mandatory that all cells must be symmetrical in shape. Based on this, we have four geometrical shapes such as circle, square, equilateral triangle, and hexagon. If we select the shape of a cell as a circle, then the area between the two circles will not get covered by the base station, and any attempt of communication from that area will fail. Thus, we eliminate the circular shape. Hexagon has the highest area as compared to the other two shapes. Thus, we divide the geographical area into hexagonal cells. The next concept is a cluster. A group of cells is called as a cluster. The cluster size is not fixed. It depends on the requirements of the area. Let's study the mobile phone system now. The basic structure of the mobile phone system is as shown, where MS means mobile station, BTS is base transceiver station, BSC is base station controller, and MSC is mobile switching center. In this diagram, MS is nothing but the mobile phone of a user. Every cell has its own base transceiver station at its center. Whenever a call is sent out, the first signal is sent to the base transceiver station of the cell. From this base transceiver station, it goes to the central base station controller, which controls the working of all the base stations. From BSC, it then goes to MSC, or Mobile Switching Center, which is the master controller of the entire system. These MSCs are different for different areas. From MSC of Area 1, the signal is transmitted to MSC of Area 2, where it follows the reverse sequence as MSC to BSC, BSC to BTS, and from BTS to MS. Whenever a user makes an attempt to call someone, a separate channel is assigned to the user by the MSC. If all the channels are already occupied by other users, then this user has to wait for a channel to become free. In such a case, the user gets the notification such as call cannot be completed, or network error, etc. Hey, it's time to concentrate now. Now let's see the features of the cellular concept. Its first feature is frequency reuse. In frequency reuse, same set of frequencies are used for radio channels located in different areas. As shown in the diagram below, every cell named as A uses the same set of frequencies. The advantages of frequency reuse are many transmitters of small output power operating at the same frequency can be used. It reduces the minimum height of the transmitting antenna as each antenna has to cover a small distance. But the disadvantage is that if the system is not properly designed, then it may lead to co-channel interference. Co-channel interference is a phenomenon in which two frequency signals of adjacent channels interfere with each other. The second feature of the cellular concept is cell splitting. In cell splitting technique, each cell is divided into smaller cells, known as microcells. The radius of these small cells is half of the original radius. Cell splitting technique proves advantageous when the traffic of cell phone users increases beyond the limit of a regular cell. Let's see what do we mean by a handoff procedure. Consider a situation where we are traveling from place A to place B via a car. Sometimes it happens that for a short period of 2 or 3 seconds, the signal strength on mobile is very low, and again it increases and reaches its normal level. Have you ever thought why this happens? The answer to this question is the handoff procedure. When someone, user X, travels in area A, he receives the signal from base station A. That is, antenna A has a strong hold on out device's signal. But as he moves away from antenna A, the signal strength gradually decreases. At a boundary of cell A, the hold of antenna A on the device is minimum. At the same time, when the device is about to enter into cell B, base station B starts to take hold on the device. Thus, at the border of cell A and cell B, both the antennas have equal amount of hold on the device of user X. As user X crosses the border and enters into cell B, area B, strength of base station A very rapidly decreases, and strength of base station B rapidly increases. In short, the device receives the signal network from base station B. But during this procedure, the call is still on. Hence, base station A handovers this call to base station B without any effect on the call. This procedure is known as the handoff procedure. This process happens so rapidly that the user never notices it. We all know that there are 2 types of systems available as GSM and CDMA. We will only study the basics of GSM system. GSM stands for Global System for Mobile. GSM is nothing but a big system made up of few small systems, such as mobile stations, MS, base station subsystem, BSS, network and switching subsystem, NSS, operating subsystems, OSS. The architecture of this GSM network is as shown. Mobile station, MS. MS is nothing but the device used for communication, such as cell phone, fax machine, etc. Base station subsystem, BSS. BSS gets connected to MS via radio interface. It has 2 different blocks as BTS, base transceiver system, and BSC, base station controller. Practically, every MS gets connected to BTS of that area. This BTS sends the signal to BSC. Many BTS are connected to one BSC, and at the end of this, BSC is connected to MSC. Hence, BSS system consists of BTS and BSC. Network and switching subsystem, NSS. This system mainly contains MSC. MSC is the backbone of the entire network. It controls all the operations from setting up a call till the handoff procedure. Other blocks of NSS are HLR, home location register, which keeps the database of all the users who reside in the same geographical area. VLR, visitor location register, keeps the track of all the users for that particular geographical area, mainly roaming customers. AUC, Authentication Center, mainly controls the authentication of the users by checking their SIM numbers, etc., and sends the required information to the MSC. Let's take a quick review of what we have learned. We started with the cellular concept where we learned that every geographical area is divided into hexagonal-shaped small areas called as cells. A group of such cells is called as a cluster. After that, we studied the basic structure of the mobile phone system, where MS means mobile station. BTS is base transceiver station. BSC is base station controller. And MSC is mobile switching center. Whenever a call is initialized, a signal follows the sequence as MS to BTS, BTS to BSC, BSC to MSC of area 1, from MSC1 to MSC of area 2, from MSC to BSC, from BSC to BTS, and from BTS to receiving MS or user. Next, we studied two features of the cellular concept, such as frequency reuse, in which the same set of frequencies are used for radio channels located in different areas, and cell splitting, where each cell is divided into smaller cells known as microcells. Next, we studied the handoff procedure, where we learned how a control over a call is transferred from one base station to another base station when a user travels from one area to another. Lastly, we saw a GSM system consisting of different subsystems as mobile station MS, base station subsystem BSS, network and switching subsystem NSS, operating subsystem